All right, let's see another example of a cyclohexane. We'll make this one a little bit more complicated. And let's draw this compound. Now this is a disubstituted cyclohexane. We have two different R groups on our ring. One is a methyl and one is an OH. Now to draw this, we need to specify relative orientations. We haven't talked about this really yet, but as it turns out, these two groups, there are multiple ways they could come off the ring. They could both be oriented on top, coming out above the ring, as drawn, or one could be above the ring and one could be below the ring. Let's keep the methyl group up, put the OH down. I'm going to stick with this one. This is something that they call the cis isomer of this compound, because both of them are up. They're both up. So they're cis, they're together. This is referred to as a trans compound because, one is up and one is down. So they're kind of opposite each other. They're trans to each other. So let's stick with the cis compound. So let's draw our chair. I always draw this chair first, just out of habit. Now let's number our carbons. 1, 2, 3, 4, 5, 6. This will be carbon 1. Carbon 1, there's a group oriented down and a group oriented up. The group down is going to be axial. I said I want to have the methyl group up, so let's have the methyl group equatorial up, and that means the down group must be a hydrogen. Now, I'm not going to fill in all the groups because it just takes time. We've seen it multiple times before. You should practice it, be comfortable with it, but I'm not going to do it in this video. So that's carbon 2, and that's carbon 3. Now, we want to make sure when we draw the OH group, this OH group, if the methyl group is up, then the OH group is also going to be up. Well, on this carbon 3, we have an axial down and an equatorial up. Our down is going to be the hydrogen on that carbon, and there's our OH. Now, we'll just fill in these carbons, but now, just because we haven't drawn them doesn't mean that carbons 4, 5, and 6, as well as 2, don't have hydrogens on them, an axial and equatorial hydrogens. So, let's look at what happens when we flip this. Let's draw the other conformation of this ring, the other chair conformation. Here's carbon 1, 2, 3. Carbon 1, this methyl group, which is equatorial up, when we flip it, it's going to bend upward. And now the methyl group is still up, but it's axial up. And the hydrogen is going to be equatorial down. Let's go to carbon number 3. Carbon number 3, this OH will go, it's up here and it's equatorial. It will still be up here, but now up is axial. And let's draw our center point. Our equatorial hydrogen is sticking out like that. So here's another case where we have these two groups. Once we start putting our big groups axial, they really start to bump into each other. Again, this is a steric effect. So we'd say this conformation is less stable, and this is more stable. Note that when you draw these chairs, you have to be very careful of whether things are equatorial or axial, whether they're going to be cis or trans. Note that this is still cis. This doesn't look very cis, but the fact is this methyl group is up and this OH is up. They have the same orientation on the ring. We are still drawing the cis compound. I think it's a little easier when you look at this conformation to say, oh yeah, that methyl group is up, that OH is up. Those are clearly both together. When things are equatorial, it's a little harder to see, but they still have a distinct orientation. So we have to make sure that we're consistent in how we draw these. We said at the opening we want to draw the cis. We got to make sure that both of these conformations are indeed cis, and we were careful, and they are cis. So there's nothing tricky about cyclohexanes. Really, a lot of it gets into making sure your chair initially is drawn properly. And if your chair is drawn properly, then it's much easier to place your different R groups in the chair. And once you have a decent chair drawn and decent R groups in the right positions, it's easy to make judgments on which is better and which is worse, this is all about weighing the energies of different conformations.